All right, so for this one, given the quadratic function y equals x squared plus 4 and the linear function y equals x plus b, so that is a rough sketch. You should know enough about these. This is a parabola that's up 4 units. Y equals x plus b, that's a straight line with a slope of 1, but you don't know what the b is here. That's the y-intercept. So it could be, down here, it could be here touching once, it could be here touching more than once. So we kind of have to find out what values or range of values these intercepts could be to match with these solutions. So you can kind of tell that whatever this one is right here, that's going to be the cutoff point for, that's going to be exactly one solution. See that? And then anything less than that is going to be no solutions, and anything greater than that is going to be 2 solutions. So clearly this intercept is really important. Okay? So what happens at this intercept is where this line right here touches the parabola. So they do share a point. They share a point. Okay, that's going to be helpful. If they share a point, that is, they share an x and y value, I wonder if we could just let each of these equal each other and then try and solve for b. You know what I mean? So they're the same point. Determine all possible values b that result in a system of equations with. Yeah. So we need to try and find out what b is. So let's try that. Let's try y equals x squared plus 4. And y equals x plus b. We don't know what b is, but let's see if we can crash these two together. So we'll do a substitution here maybe, and let's just see what happens there. So b, x plus b equals x squared plus 4. Okay, so if we try and figure this out, if we get all the terms to one side, we have x squared minus x minus 4, minus b plus 4, minus b plus 4. Okay. Equals 0, right? So I do kind of have a quadratic here. This is one term, this is a second term, and this is a third term. That's my constant. But my constant has an unknown part to it. So I could treat this whole thing as c. I wonder if that would work. Because if I have this crash together now, really what I'm trying to find is where are the intercepts, right? This is now a parabola that's been brought down, and I'm trying to find, if I find the roots, that's where it'll be this point and then this point over here, really. So if I let that equal 0, I might be able to solve for b. Now I don't know what the answer is to this either. So this is what I'm kind of thinking. Now, is there another way we could do this? I don't know. Did anyone try this and use the quadratic formula for this? Hands up, yes?
I tried the discriminant thing where it's d is equal to b squared minus 4.
Okay, yeah.
And that's what I did. I used the b plus 4 as the c.
Yeah, so b squared minus 4ac. Now c has this, right? So b is a number we know, a is a number we know, c has the unknown value in it. So if the discriminant is 0, we have one solution, right? Which is exactly what we want. So that would be the best way to go. I think you're right. So if we let this equal 0, that will give us one solution, which means I actually find this this x value right here, because that's where they only touch once, right here. Okay, so b is -1. This is a tough one. This is a tough one. So don't feel bad if you didn't get this one. 1 and then times c, which is minus b plus 4. This is going to have to be minus b minus 4, b minus 4, minus b minus 4. If I make this one thing, I think I have to change this to a minus, right? Because I need to make this one whole unit here. So that's going to be negative b minus 4. It's going to be negative. Yeah, so negative b plus 4 is fine. It's just like that's expanded out, negative b plus 4. I think that's okay. I think that's okay. Let's try it. So this is 1, this is going to be 4 times, negative 4 times negative b, so that's going to be plus 4b, and that's going to be negative 4 times positive 4 minus 16. So 1 minus 16 is negative 15, that's a positive 15 over here.
But I thought we already knew what B was.
Yeah, b, okay, so the b here, this b is the coefficient here. This b is our unknown part. So there's two different, yeah, there's 2 different b's in this question, actually.
You can't just square root x squared and then square root 4?
No. Like square root this?
Yeah.
No, unfortunately not. You can't, no, because even though those are perfect squares, the sum of them, you can't, this isn't equal to x plus 2, if that's what you mean. Yeah, no, that's a common mistake. We can't actually do that, because we'd have to take the square root of this side too, which would mess us up. That wouldn't really help us much anyways. So I think this is 15 over 4. Can anyone confirm that that's what b is? Does that look, that's the right answer? Okay. So b is 15 over 4 will give us this one solution, because the discriminant will then be equal to 0, which the discriminant gives us one solution. Okay, so why is this important? Because exactly one solution, b equals 15 over 4, and 2 solutions, as we mentioned, because 15 over, oh, wait a minute. Yeah, b is this, yeah, it would be this b value, I guess. So 2 solutions would be anything is b greater than 15 over 4, and no solution would be b would be less than 15 over 4. Less than brings the line down here, which doesn't touch the problem at all.
Is this going to be a question, like a question on the
You might probably not get a question this detailed on the final, I'm guessing.
And
But
if we do, we're probably going to be like
if you do, then you know how to do it. Yeah. And it'll probably take you 10 minutes to do.
yeah.
But yeah, so that's, I mean, that's an upper level challenging one.
Yeah. That's a,
Guaranteed that most of the questions on the final will not be like this, not be this hard.
It's like one of those wonders questions.
Okay. So the sum of the squares of 3 consecutive integers, so that's going to be like x plus 1, x plus 2. That'd be a good idea. So the sum, okay, we're going to add what? The squares of those. So that's x squared. We're going to add that to x plus 1 squared, and then x plus 2 squared. That equals 194. Does that match up with the question?
Yep. Yeah.
Okay. Now these could be positive or negative integers, I guess. So I don't know if there's one set or 2 sets. But yeah, so this is we've got one variable in one equation, so that's good. We should be able to solve it. You're probably going to have to expand and gather some like terms, I guess, so we can get down to one quadratic. So x squared, this is going to be plus x squared plus 2x plus 1. And then x squared plus 4x plus 4 equals 194. Gather like terms, so 1, 2, so it's 3x squared. We've got 2x and 4x is 6x, right? Plus 6x. And then we've got 1 and 4, so that's plus 5. And then we may as well bring that 194 over here, because we do want to get equal to 0 eventually. So 3x squared plus 6x. This is going to be negative 189, looks like. 189. All right, so we got a quadratic. Now we're going to try and find the solutions here. Now, the x is our first number, and they should be integers. You see that? So this actually might not be that difficult to solve by sight. You could use quadratic formula, you could use decomposition, you could solve by intuition. I'm going to try this, just solving or factoring straight, just in our minds here, because 3 is prime, so that's going to be 3x and x for sure. Now the big thing is, what are the factors of 189 that could fit in there? So do you have an idea?
Divide by 3?
Oh, maybe. Yeah, I don't know. Yeah, you could maybe divide. Does 189 divide evenly by 3? Yeah, it is. It's 63. Okay. So okay, let's do that then. So that's 3. This is 2. And that's 63. Yeah, then that's really easy to do then. So this is x and x. So we've got like 7 and 9 looks like, right? So 7 and 9, we're going to do plus 9 and minus 7 to get us plus 2, right?
Yeah.
Okay. So yeah, so that one is really easy. So the x is equal to, this is important, negative 9 and positive 7. So they could be positive or negative, the answers, right? That it just says integers. So it's possible that this could be negative 9, negative 8, and negative 7, or 7, 8, and 9. Because we're squaring them, the squares become positive.
So the answers are like the two farthest out, and then the rest integers in between are also the answers you could ask.
So the three, well, it says what are the integers that satisfy this question.
Yeah.
The integers are, negative 9, negative 8, negative 7. That's one group of solution. And then positive 7, 8, 9 are the second
So like
group.
the answers are like 9 and 7, and then you just get all the numbers in between.
Yes,
That-
yeah, you start with negative 9, and then you add 1 to it, you add 2 to it.
Okay.
Like from the original question.
So
And then
7,
7, and add 1 to it, add 2 to it.
Okay.
Yeah. Is it about this question or something else? Yeah.
Anything on a piece of paper?
Yeah.
Could you show how to do 11 in the same review?
Okay, so just to kind of help on this one. So the outdoor tub has a diameter of 2 meters. So there's the tub, the blue, the tub. And it's surrounded by a wooden deck. So you see the picture of the wooden deck. So that the deck has a uniform width. So that means that this value right here is the same all the way around. It's perfectly in the middle, this tub. If the top area of the deck and tub, so that's this whole area, right? The area is 63.6 meters squared. How wide is the deck? So we have an unknown portion here. That's the width of the deck. That's x. So how does area of a circle, how does that area and a circle relate? Well, the area of a circle is pi r squared, right? And in this case, what would be the r for the larger circle? Now be careful, think carefully. What's the radius of the larger circle?
Something plus 1.
Okay, yeah. So half of the hot tub is 1 meter, right? And then plus x. Yeah, so r is x plus 1. So you've got 63.6 equals pi times the radius here is x plus 1 squared. And then you go ahead, and I'll let you finish that off, and then you solve for x there, okay?
I must have put it as x plus 2.
Yeah, maybe you did x plus 2. That's correct. Yeah, could have been. So did you guys finish that number 11? Did you finish number 11 there? Looks like you should get 3.5 meters as the width of the deck surround, so.
3.5? 3.5 is the radius of the is the diameter.
Yeah, the width of the, looks like it should be the width of the deck there. If you do this, divide by pi here, and then expand this x plus 1 squared right here, and then subtract this over, then you'll get this as a number for c. And if you plug that into your quadratic formula, so a is 1, b is 2, c is this, then you should get 3.4999 as one of the answers. The other one will probably be, is going to be negative. So.
I just rounded, like, instead of having 8.9, I just rounded up to 9.
Try and keep as many decimals as you can during the question, then that'll help. Yeah.
So on this thing says this for the sum of